Okay, my recorder cut off about halfway through that last clip, but it cut off at a good time. I'd posed the problem y prime of t equals 2, 3, negative 1, 6 times y of t with y of 0 equal 1, 1. We want to apply the propagator matrix to solve this equation, this initial value equation system. Okay, we know that we can get a psi matrix for this equation. We're going to get eigenvalues 3 and 5, giving us eigenpairs 3 and 1, 3, 5 and 1, negative 1, yielding this solution and this solution to the homogeneous equation. So we have a psi matrix representing our general solution. The inverse of that matrix is easily found. The determinant of the matrix is we're going to have an e to the 8t either way we multiply this. We're going to have a negative e to the 8t and then a negative 3 e to the 8t, giving us a negative 4 e to the 8t. So that our determinant is going to be negative 1 over 4 e to the 8t. Easy to invert a matrix if we keep our wits about us, especially a 2 by 2 matrix. We don't even really have to resort to row reduction. We can almost do it by inspection. In any case, the inverse of this matrix is then the determinant multiplied by these entries. And if we multiply the two matrices, ignoring the constant out in front for the moment, if we multiply this by this, we're going to get negative 4 e to the 8t. And then if we multiply this by this, we're going to get 0. This times this is going to give us 0. This times this is going to again give us negative 4 e to the 8t. So that we're going to have from this matrix times this matrix just negative 4 e to the 8t on our diagonals and 0 off the diagonal. So that when we multiply by negative 1 over 4 e to the 8t, we get 1s on the diagonal, 0s off the diagonal, showing that these matrices are inverse to one another. So using the inverse matrix in the original matrix, we can form the phi matrix, psi of t times psi inverse of s. So psi of ts equals psi of t psi inverse of s. Here's psi of t, the same as it was down here. And psi inverse of s, now I've written the negative 1 over 4 e to the 8s in this case because, of course, we're doing psi inverse of s. The t has to be replaced by s. I've written that to the right here just so we can have the matrices right next to each other. Scalar multiplication by a matrix is commutative, so there's no problem with that. So we can see these matrices and how they line up. Now, a couple of things we can notice, and in the previous incarnation of the clip, I actually wrote some of these things out on camera, but it's very easy to multiply these matrices, and you can actually skip on down to here if you think you can do that matrix multiplication, and multiplication by the scalar. But e to the 3t times e to the 5s is e to the 3t plus 5s. And we have a negative, so we get a negative e to the 3t plus 5s. And e to the 5t times negative 3 e to the 3s, again, we're going to get 5t, well, this time we're going to get 5t plus 3s for the exponent, and we'll have a negative 3. And similarly, for this row times this column gives us this row times this column gives us this row times this column gives us this. All still multiplied by the negative 1 over 4e to the 8s, which I can't even read that there, but it's the same as what it was here. Now, an interesting thing happens when we divide by the e to the 8s. That's going to reduce the coefficient of our s's here by 8. So the 3t plus 5s is going to become 3t minus 3s, which could be factored to give us 3 times t minus s. And that's the way we have it here. And 5t plus 3s, if we reduce the coefficient of s by 8, we get negative 5s, which gives us 5t minus 5s factored 5 times t minus s. This happens throughout. And again, it's not a difficult exercise to just multiply these two matrices and see this for yourself and see how it works out. I recommend this. So at this point I've divided by the e to the 8s. I still have the negative 1/4 out here, which I then distribute through the matrix. And this time, taking a little bit of liberty with the notation, I write this as 5t minus s. Now, if phi is a function of two variables, it's not a function of one variable. But your book does this, and it's commonly done. Just again, taking a little bit of liberty with the notation here. Okay, so where are we? We've got the phi of t minus s matrix. And if we go back here to what I at least asserted, y of t should equal phi of t t naught times y of t naught, or phi of t t naught times y naught. Okay, the system we have here, t naught is 0, and y naught is the vector 1, 1. So if we replace s by 0 and multiply the resulting matrix by the 1, 1 vector, we should end up with a solution to our initial value system. I'm going to keep the clip short because the computer malfunctions every once in a while, and just in case this one doesn't work, it won't take too long to redo it.